Hi all, in this video let us learn about application of Laplace transform. The Laplace transform is a very efficient method to solve differential equation problems. The Laplace transform takes a differential equation and turns it into an algebraic equation. Further, this algebraic equation can be solved by applying the inverse Laplace transform, which gives us a desired solution. Now let us see the procedure for solving differential equation using Laplace transform technique. The very first step is we have to take Laplace transform on both the sides of the given differential equation, and then we have to apply the given initial conditions given in the problem. We have to simplify, then we have to solve it for L of y of t. We have to use the partial fraction technique, and then we have to take inverse Laplace transform and get the desired solution. Now let us work out an example problem which will help us in understanding the procedure for solving the differential equation. So using Laplace transform technique, solve y double dash minus 3y dash minus 4y is equal to 2 into e to the power of minus t. The initial conditions is y of 0 is equal to 1 is equal to y dash of 0. So the very first step is we have to take Laplace transform on both the sides of the differential equation. So that will be L of y double dash minus 3y dash minus 4y is equal to Laplace transform of 2 into e to the power of minus t. Now applying the linearity property, we'll be having L of y double dash minus 3 into L of y dash plus minus 4 times L of y of t is equal to, it is 2 times L of e to the power of minus t. Now let us use the formula for L of y double dash, L of y dash and L of e to the power of minus t. Then we have to solve it for L of y of t. Now we know that what is L of y double dash is. L of y double dash is nothing else. It's s square into L of y of t minus s into y of 0 minus y dash of 0. Now here we know that what is the value of y of 0 and we know the value of y dash of 0. Y of 0 is 1 and y dash of 0 is 1. We can substitute here. Then now what is L of y dash is? L of y dash will be s into L of y of t minus y of 0. Here also instead of this y of 0 we can substitute 1. And also we know that the Laplace transform of e to the power of minus t will be equal to 1 divided by s plus 1. So now let us substitute these three values, that is L of y double dash value, L of y dash value and L of e power minus t value in this equation. We will substitute and then we will simplify it. So when we substitute L of y double dash as, it's nothing else s square into L of y of t minus s into y of 0, y of 0 is 1, then minus y dash of 0, y dash of 0 value is 1. So this is for L of y double dash, and the second term will be minus 3 times L of y dash. It will be s into L of y of t minus y of 0, y of 0 value is 1. Then the next term will be minus 4 times Laplace transform of y of t is equal to 2 times L of e power minus t is 1 by s plus 1. Let us simplify this term. This is equal to s square into L of y of t minus s minus 1. Multiply each term with minus 3. We have minus 3s into L of y of t. Then minus of minus, it will be plus 3 minus 4 times the L of y of t is equal to 2 by s plus 1. Let us further simplify, let us collect the terms of L of y of t. Here one term is here, here one L of y of t and here one L of y of t. Let us collect this term. So we'll be having s square minus 3s minus 4 into this L of y of t, because we are going to solve it for L of y of t. Then 1 minus s term is here. Then we got this minus 1 and plus 3. It will be plus 2 is equal to 2 divided by s plus 1. So let us further simplify. This is nothing else s square minus 3s minus 4 into L of y of t is equal to, it is 2 divided by s plus 1 plus s minus 2. Now we have to take an LCM here and then we have to further simplify this one. So that means your s square minus 3s minus 4 into L of y of t is equal to, it is 2 plus s into s plus 1 minus 2 into s plus 1 whole divided by s plus 1. So I took an LCM. So this is equal to 2 plus s square plus s minus 2s minus 2 divided by s plus 1. So this plus s 2 and minus 2 will be getting cancelled. So it is equal to s square minus s divided by s plus 1. The same way when it comes to this side, here this term can be factorized. For minus 4, the factors will be 1 into 4 is 4 and we need a minus sign. So 1 into minus 4 will be minus 4 and 1 minus 4 will be minus 3. So we'll be having s plus 1 into s minus 4 into L of y of t is equal to. So therefore we got L of y of t is equal to s square minus s divided by s plus 1 into s plus whole square. Okay, we can take it as s plus 1 into s plus 1 will be s plus 1 the whole square. Then we'll be having s minus 4. So this is what the final simplification we are having. Then further we have to do partial fraction technique for the right hand side part, and then we have to break them into some of the s terms so that we can apply very easily the inverse Laplace transform technique. So let us now do the partial fraction technique. For the partial fraction technique, for that part we will consider this equation s square minus s divided by s plus 1 the whole square into s minus 4, which is equal to a divided by s plus 1 plus b divided by s plus 1 the whole square plus c divided by s minus 4. So for this term s plus 1 the whole square, we have to take a by s plus 1 linear term, then b divided by the quadratic term s plus 1 the whole square. For the third factor s minus 4, we will be taking c by s minus 4. Now let us take an LCM. If we take an LCM, we will be having s square minus s is equal to a into s plus 1 into s minus 4 plus b into s minus 4 plus c into s plus 1 the whole square. Just I took an LCM for the terms. So now let us find the values of a, b and c. For finding the value of a, we can, first of all, let us find the value of b. For finding the value of b, let us take s is equal to 4. If you substitute s is equal to 4, the coefficient of this a component, if we substitute s is equal to 4 means this a component and b component will vanish out and we can very easily find the c component, c values of c. Similarly, if you take s is equal to minus 1, we can very easily find the value of b. Then we can compare the constant coefficient for finding the value of e. So let us go for it. Let me take first of all s is equal to 4. If we substitute means we will be having 16 minus 4 is equal to, so here the first term will be vanishing out and my second term will be vanishing out and my third term will be c into 4 plus 1 5 square, or otherwise the value of c is equal to, here 16 minus 4 will be having 12, c into 25, so this implies value of c is equal to 12 by 25. Similarly, we take s is equal to minus 1. If we take s is equal to minus 1, we will be having minus 1 the whole square. Minus of minus 1 is equal to, my first term will vanish out, second term will become minus 1 minus 4 minus 5, third term will vanish out. So here 1 plus 1 it is 2 is equal to minus 5b, or otherwise this implies value of b is equal to, it is minus 2 by 5. Now to get the value of a, let us compare the coefficient of constant. We can either compare coefficient of constant or coefficient of a square also. If I compare coefficient of constant term now, in the left side there is no constant, so I will be having 0. So here on the right side the coefficient of constant term is this a into this minus 4. So I will be having minus 4a. For the second term it is minus 4b, and for the last term it will be c. So let us substitute the values of b and c in this equation. If we substitute now, we'll be having 0 is equal to minus 4a minus 4 into minus 2 by 5, then plus 12 by 25. So when we simplify this term, we'll be having 4a is equal to, it is 52 divided by 25. On simplification, we will be getting the value of a as 13 divided by 25. So now we got the value of a, we got the value of b, we got the value of c. Now let us substitute these values in the partial fraction. We'll be having our L of y of t is equal to, it is 13 by 25, that is the value of a, divided by s plus 1, plus the value of b is minus 2 by 5, so minus 2 by 5 divided by s plus 1 the whole square, and the value of c will be 12 by 25, so 12 by 25 divided by s minus 4. So what is y of t? Y of t is equal to, it is 13 by 25 into L inverse of 1 by s plus 1 minus 2 by 5 into L inverse of 1 by s plus 1 the whole square, and then plus 12 by 25 into L inverse of 1 by s minus 4. So it is equal to 13 by 25 into L inverse of 1 by s plus 1 will be e to the power of minus t, then minus 2 by 5 into L inverse of 1 by s plus 1 the whole square. Let us first apply the shifting property. We will be getting e power minus t, and L inverse of 1 by s square will be t. So it will be e power minus t into t. Then finally it's plus 12 by 25 into e to the power of 4t. So this is the value of y of t. So the solution for the differential equation will be 13 by 25 into e to the power of minus t minus 2 by 5 into e power minus t into t plus 12 by 25 into e to the power of 4t. So in simplified form, so first of all we have to take Laplace transform on both the sides for the differential equation, then we have to apply the initial condition, and then we simplify, and we have to find what is L of y of t is equal to. We have to find it out. We have to apply the partial fraction technique, and then take an inverse Laplace transform, and then we have to get the solution. So in the next class, we will see another problem. Thank you.